Colby, 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 math.com.
We're practicing multiplying mixed numbers on tonight's assignment. There's a common error that students make when they multiply mixed numbers, so I'm going to go through that common error, but I'm going to ask you to just follow along and not necessarily write this part down. Sometimes when students multiply mixed numbers like 6 2/3 multiplied by 4 1/5, they make the mistake of just multiplying 6 times 4 and adding the product of 2/3 and 1/5. That's incorrect, and I'll show you why. If we make an area model, a rectangle, and imagine that the base is our 6 2/3. Well, 6 2/3 is literally what it sounds like, 6 2/3. So this part might be 6. From here to here might be 6 feet maybe, and this little extra bit might be 2/3 of a foot. There's your 6 2/3. And if we look at the height, from here to here could be 4 feet, this distance, and this little extra piece could be our 1/5. If we break the rectangle up into 4 pieces like this 24 is this area, and the 2/15 we would get here is 2/3 times 1/5 is this piece, but we're missing this whole piece and this whole piece. So you can't get the full product if you simply multiply the whole numbers and multiply the fractions and add them, because you have two terms in each of these factors. You would need to distribute this 6 to both of these terms. You have to do 6 times 4 plus 6 times a fifth, and then you would have to do 2/3 times 4 plus 2/3 times a fifth in order to get all of these pieces. And using that double distribution, it's just way too complicated, so that's not what we normally do with mixed numbers. What we normally do with mixed numbers, and what I hope you will do now, is represent each mixed number as an improper fraction. In other words, if I convert 6 2/3 into an improper fraction, I do 3 multiplied by 6 is 18, and I add 2 to get 20/3. And when I convert 4 1/5 into an improper fraction, I do 5 times 4 is 20, and I add the 1 to get 21/5. The reason this works is every whole, if I'm counting thirds, every whole is 3/3. So if I have 6 wholes, I have 3/3 and 3/3 and 3/3 and I have 6 of those. 6 3/3 is 18/3, plus the extra 2/3 is 20/3. Similarly, if I'm counting fifths, every whole is 5/5. If I have 5/5 plus 5/5 plus 5/5 plus 5/5, there's my 20/5, plus one more fifth for 21/5. And once you have them written as improper fractions, then the multiplication becomes very simple, because you just do 20/3 multiplied by 21/5. And you could just multiply numerator times numerator and get that product, denominator times denominator and get that product for your denominator. But then you'll have a lot of simplifying to do, which is fine. I mean, if you do it that way and you simplify carefully, you'll still get the correct product. But there's a much more efficient, easier way to do this. So why don't you, during the pause, see if you can remember how to do that, and then we'll come back after the pause and explore that together.
Paused.
Since we multiply numerator times numerator and denominator times denominator, and since multiplication is commutative, I could rewrite this as 21 times 20 over 3 times 5. I could just leave the denominator as is. Do you see 21 over 3 is just 7. 21 divided by 3 is 7. And 20 divided by 5 is just 4. That's why we can do this when we have, when we look at our multiplication expression before we multiply. If any numerator and any denominator in a multiplication expression have a common factor, like 20 and 5 have a common factor of 5, you can divide the numerator and denominator by that common factor. 5 divided by 5 is 1, and 20 divided by 5 is 4. Similarly, the 21 and the 3 have a common factor of 3. 3 divided by 3 is 1. 21 divided by 3 is 7. And so we get 4 times 7, which is 28, over 1 times 1, which is 1, and that's just 28. Just like the other puzzle problems, you don't need to do the shading, do the puzzle part, but just make sure you see 28 somewhere on that grid. If you want to do the shading, everywhere you see a 28, you would follow this pattern and shade the lower left corner of each square that has 28, and use the code for the answer to each problem, and you'll get an interesting pattern on this grid if you're interested in doing the puzzle part. Thanks for watching the video. I'll see you tomorrow.